properties of definite integral, what we will do, we will take the property or the theorem, and we will take an example on that theorem until we cover all the properties regarding the definite integral. Now the theorems say as b larger than a and less than c, the integration from a to c f of x dx equals the integration from a to b f of x dx plus the integration from b to c. So you can have b as a common point or a split point between the two integrations, but there's a condition: b should be a point less than a, and b should be a point smaller than c and larger than a. You can see in the curve here, you have a function, then you have point a on the x-axis and point c. Integration will take the area under the curve, but you can create a point b as long as it's in between those points and it is lying under the curve to split the integration, if that makes your life easier finding the solution. So the example is saying find the area under the graph of y equal f of x from -4 to 5, where f of x is represented as 9 as x less than 3 and it is x squared as x larger or equal to 3. So the function look like this on the Cartesian. As x is less than 3 over here, the f of x equals 9, so it will be a straight line on the y-axis to the value of 9. After 3, the function f of x would equal to x squared. You will start to have a curved representation of the function over here, but you are interested to find the area under the whole curve in this case. So find the area under the graph or under the curve for y equal f of x, and he's giving you a limit from -4 to 5. So from -4 on the x-axis to 5, you need to find the area under the curve for those two functions, or for that function that's split into two different representations in a different intervals. The integration from -4 to 5 of f of x dx would equal the integration of -4 to 3 of f of x. So it will be easier to take it from here to here than from here all the way to here. So we can split the integration into two integrations as long as point 3 is in between the points -4 and 5 and under the curve. So f of x from -4 to 3 would equal to 9, and plus the integration from 3 to 5, the f of x is x squared. Now taking the integration as a constant, the integration for that would be 9x from -4 to 3. So don't be confused. I don't like the way they represent here, it's confusing. So integrate the 9, forget about the borders, integrate the 9, that would give you 9x. 9x, do it from -4 to 3, that would be plugging in the 3 instead of x here, minus plugging in the 4 instead of x here. It will be 9 by 3 minus 9 by the -4. And that's what he's doing here. And that would be plus the x squared would equal as integration x cubed over 3 from 3 to 5. Plug in the 5 minus plug in the 3 instead of x. That would give you 5 cubed over 3 minus 3 cubed over 3. It will give you a certain value. Then you will add the value you get here with the value you get here. Then you will get your final answer as 95 multiplied by 2 over 3 as the area under the curve that you can see in the Cartesian. Let's take an example with a little different functions. If you have the absolute value of x as a function for your integration, he's asking you to integrate from -3 to 4 of the absolute value of x dx. What you're gonna do, you need to know from your algebra and our crash course for preparation of the Calculus 101 that the absolute value of x can be represented as -x and x. -x as x less than 0, and the absolute value would be x as x greater or equal to 0. Now taking the integration for the absolute value would be split into two integration by nature. So if we take the integration from -3 into 4 of the absolute value of x, we need to split that absolute value. We can't integrate right away. It will be -3, anything in a negative value, anything less than 0 would be the integration from -3 to 0 of the function minus x, in this case dx, plus the integration from 0 into 4, so minus 3 to 4 would be minus 3 to 0 and 0 to 4. From 0 to 4, when the values are positive or x greater or equal to 0, the f of x would be equal to x dx. Now, find the integration, plug in the values, you get your final answer. Minus x would be minus x squared over 2 from minus 3 to 0 plus x would be x squared over 2 as integration from 0 to 4. So minus x squared over 2, 0 would be equal to 0 minus, because we have the top value minus the bottom value compensation, minus the minus 3 squared, that's minus 3 squared would be 9. So minus the minus 9 will be plus 9 over 2 plus x squared, that's 4 squared, that's 16 over 2, which is 8, minus whatever value would be 0. So you have 9 over 2 plus 16 over 2, which would give you 25 over 2, as you can see here. I will keep B for you to be able to train yourself on that. So you can pause the video over here and try to solve by yourself. In a second, I will show you the solution for that. So the solution for B, the next theorem about definite integral properties. Let the f and g be continuous functions, and suppose f of x is greater or equal to g of x over the interval a and b. What is the area under the curve representation? The area under the curve representation would be the integration from a to b of f of x minus gx dx. So you have here a function g of x that's covering this area or this curve. We have f of x covering this curve. Now, how to find the area between those two functions under the curve between the points A and B? So you have the limits of your integration between A and B. What is the area under the curve? It would be represented as the integration from point A to point B, so from A to B, of f of x, which is the top function f of x, minus the function g of x dx. Doing that integration would give you the area. In this case, it would give you the area under the curve. Example on that. Find the area of the region bounded by the graphs f of x equal 2x plus 1, that's f of x, g of x, x squared plus 1. On the Cartesian, f of x in the blue line, g of x represented by the pink line. Now the area A is going from point 0 and 2. So first we find where does those functions cross each other by equalizing them. Where does these two curves intersect? We equalize them. F of x equal g of x, then the values of x will be x equals 0, x equal 2. So those two functions cross each other at point 0 on the x-axis and 1 on the y-axis, and on the point 2 on the x-axis and 5 on the y-axis. Now we know by doing that what is the limits of the integration. It's from 0 to 2 by equalizing those two functions. It's important to remember that if you need it. Now the integration from 0 to 2 would be integration from 0 to 2 of f of x minus g of x dx, as we learned in the theorem. That's 2x plus 1 minus x squared plus 1 dx. You can distribute the integration on that in case you need it, or you simplify the form. 2x minus x squared dx. Doing the integration needed, that would be x squared over 2 multiplied by 2, they will go together, minus x cubed over 3 from 0 to 2. Plug in 2 minus plug in 0. 0 in this case would be 0, so you have 2 squared minus 2 cubed over 3 minus 0, which is whatever in the term of 0, all of them will be 0. That would give you 4 over 3 as a final solution for this problem. Another example, I will keep it for you. So there is a clever college student developing an engine that is believed to meet all the state standards for emission controls. The engine rate of emission is given by E of t equals 2t squared, and E of t is the emission in a billion of pollution particulates per year at a time t in years. So the t is in years. The E of t is represented here as emissions in terms of physical units, a billion of pollution particulates per year. The emission rate of conventional engine is given by C of t equal 9 plus t squared. He's asking at what point in time will the emission rate be the same, and what reduction in emission results from using student's engine. The first one as a hint, at what point emission rate will be the same. So in this case, E of t would equal C of t. So the emission rate would equal the conventional engine rates. Equalizing that would give you when they would be equal at t equal 3 and t equal minus 3. What reduction emission results from using the student's engine? Then you will do the integration from 0 to 3 of the conventional engine emissions, which is C of t, minus the recommended emissions or the new engine emissions E of t. So that would be 9 plus 2 squared minus 2t dt from 0 to 3 years of use in this case. Then doing that integration would give you what is the reduction of emission from that proposed engine by the student.